Hi, hello students. Good evening everyone. I hope all are doing well. Anyway, welcome back all of you to Infinity Learn JEE YouTube channel by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. And I hope I am perfectly audible and visible to each and everyone present over here. So in this particular session, we are going to discuss the second part of our same chapter, solutions. In the last class, we have discussed about the basic introduction about the solutions, right? What about the solute, solvent, how we can classify the solutions. Then we have seen about the concentration terms, right? How to express the concentration terms of solutions. So here in this particular session, we are going to discuss the solubility part of the solutions. Ready? And I hope you guys have revised the topics that we have covered in the last class. Okay. Here's the first question. What do you mean by solubility of solutions? Solubility of solutions. Okay. While preparing the solutions, a solute is added to the solvent, right? So the maximum amount of solute that can be dissolved in a solution can be described as the solubility of a solution at a specified temperature, right? So we can define solubility as the maximum amount of solute that can be dissolved at a specified amount of solvent at a specified temperature. Clear? Hi Dhanjit, good evening. Welcome to the session. Clear? So this is the definition for the solubility of solutions. So what will happen to a solution if I am adding more solute to the solution? What will happen? Any idea? Let's say I am taking a beaker here. This is a specified amount of solvent. For example, taken as 1 liter something. So let's say this is a solution which is containing 1 liter of solvent. I can say that only 20 gram of solute I can be added here to become the solution, right? So here I am saying only 20 gram can be added. If I am adding more than that, what will happen to the solution? It will get settled there, right? It will get settled there. So there is a particular solution known as saturated solution in which no more solute can be dissolved. Is that clear? So for example, in this case of this particular solution, if I am adding 30 gram of solute, right? 30 gram of solute. What is happening here? Its maximum capacity is 20 gram. If I am adding more 10 gram of solute, it will not dissolve, right? So it will become a saturated solution here. Similarly, if I am taking the same solution, right? If I am taking the same solution about the capacity of 1 liter of solvent. Let's say 20 gram of solute is the maximum capacity of this solution, right? If I am adding only 10 gram of solute here, what will happen? What will happen? 10 gram is remaining here, right? Which means that we can add maximum of 20 gram. Here I am adding only 10 gram of solute, which means that it is less than that of the capacity of the solution, right? So we can call this solution as unsaturated solution. Is that clear? Are you able to follow my point? How we can define the solutions into saturated and unsaturated depending upon the solute concentration. Is that clear? Just let me know in the comments. Yes, fine. So we have defined the solubility of a solution, right? Maximum amount of solute that can be dissolved in the solution is known as the solubility. So that the particular solution is termed as a saturated solution, right? So here in this particular topic, we need to focus on the solubility of gas in a liquid and solubility of solid in a liquid. We can focus with the first one, solubility of solid in a liquid. Before that, we need to focus on the factors affecting the solubility. Hi Anshuman. Okay. Do you have any idea about what are the factors affecting the solubility of a solute in a solvent or solution? Definitely in the case of solution, two components are present, right? One is solute and another one is solvent. So solubility is definitely depends on the nature of solute and solvent, right? Nature of solute and solvent. So the first factor which is affecting the solubility is nature of solute and the solvent, right? Then the temperature of the system. The last one, pressure of the system. So here we need to focus on these three parameters or the factors affecting the solubility in the case of solid in liquid solution as well as gas in liquid solution. Ready? Okay, can we move to the next topic? Solubility of solid in liquid solution, right? Here solid is a solute which is added to the liquid solvent. So we will get a solid in liquid solution here. So how we can define? Just as the same, right? Solubility of a solid in a liquid at any temperature is defined as the maximum amount of solid solute. Maximum amount of solid solute is given in grams, can be dissolved in 100 gram of the liquid solvent. 100 gram of the liquid solvent to form the saturated solution, right? More solute can be added here. Saturated solution at a specified temperature or a particular temperature. Clear? Now we need to worry about the definition here. We need to focus on the factors affecting the solubility. Is that clear? Yes. So again, what are the factors? Temperature, pressure and nature of solute and solvent. We need to focus on the first parameter, that is nature of solute and solvent. For example, right, as you have already seen about like dissolves like, right? What do you mean by like dissolves like? For example, if I am taking polar solute, right? Yes, like dissolves like means if I am taking polar solute, it dissolves always in the polar solvents only, right? It dissolves in polar solvents only. So if I am taking non-polar solute, what will happen? This non-polar solute always dissolves in non-polar solvents because of their intermolecular interaction, right? Clear? For example, if I am taking salt or sugar, right? Salt or sugar, it is definitely dissolved in the water. But if I am taking naphthalene or anthracene like organic compound, right? It does not dissolve in the water. What is the reason behind that? Polar compounds always dissolves in the polar solvents only. Like dissolves like. Clear? Is that clear? Hi Prem Technical World, good evening. Is that clear how the nature of solute and solvent depends on the solubility of solid in liquid? Now what is the next parameter, next factor that is affecting the solubility? Three parameters are there. First one is nature of solute and solvent. Now let us talk about the temperature effect, right? Effect of temperature. Do you have any idea how temperature is affecting the solubility? Okay, this is the process of formation of solution, right? Solute is added to the solvent to form a solution. This particular process name is known as dissolution. Dissolution. So the process of formation of solution by mixing solute with solvent is known as dissolution process, right? So depending upon the condition of dissolution process, we can predict the temperature change there, right? how the temperature change is affecting the solubility here. For example, if I am taking this dissolution process as endothermic, what do you mean by endothermic? I hope you must have idea about thermodynamics chapter, right? What do you mean by endothermic? What do you mean by exothermic reaction? Okay, what do you mean by endothermic reaction? What is happening there in terms of heat? Endothermic. Heat is absorbing, right? Heat is absorbing there. So if you are taking the dissolution process, if the process of formation of solution from the solute and solvent is a endothermic process by absorbing the heat, we can say that according to our Le Chatelier's principle, according to the Le Chatelier principle, okay, according to the Le Chatelier principle, what will happen to the solubility? Solubility should be increase with increase in temperature, right? Increase with increase in temperature. Clear? As we have already seen in the equilibrium chapter about the Le Chatelier's principle, if you are talking about the endothermic process, always the process will forms the direction in which temperature increases, right? So here we are focusing about the solubility. So if the dissolution process is endothermic, so that as the temperature increases, solubility also increases. Then what about exothermic process? Just reverse, right? Exothermic means heat is releasing. Heat is releasing there in the case of dissolution process. So what will happen as the temperature increases? Heat releases, right? So the reaction will move to the direction where the temperature change neglects, right? So what will happen as the temperature increases? Solubility decreases. Is that clear? Is that clear? If the thing clear, just let me know in the comments. Hi Pranav. Yes. Okay. Then what about the next parameter? Pressure, right? Third parameter is pressure here. Here we are focusing about the solubility of solid in liquid, right? Solid in liquid, right? So in the case of solid and liquid, what will happen to the pressure effects? Generally, they are incompressible in nature, right? So if you are changing the pressure in the case of solid or liquid state, there is no any particular effect for the pressure, right? So we can say that pressure does not have any significant effect on the solubility of solids and liquids because they are highly incompressible. Clear? Clear? So far we have seen about the factors that is affecting the solid and liquid, solubility of solid and liquid, that is nature of solute and solvent, like dissolves like polar solute and polar solvent, and non-polar solute and non-polar solvent. Then about the temperature, right? If the dissolution process is in the endothermic process, as the temperature increases, solubility also increases. If it is an exothermic process, as the temperature increases, solubility decreases. Then what about pressure? There is no significant effect in the case of solubility of solid in liquids. Clear? Yes. Now let us talk about the solubility of gas in liquid. Here we discussed about the solid in liquid, right? Now we are changing the solute in the gaseous state, gaseous solutions, right? I am adding a gas solute in liquid. A gas solute in liquid. As we discussed earlier, the solubility is defined as the maximum amount of solute that can be dissolved in the particular amount of solvent at a particular temperature. But in the case of here, this solubility is expressed in terms of mole fraction or molarity, right? Molarity or mole fraction of the gas. Clear? If you are talking about the solubility of gas in liquid, here the solubility can be expressed in terms of either molarity or the mole fraction of the gas. Clear? So here we are discussing a new law known as Henry's law. Henry's law. Before that, again we need to talk about the factors affecting the solubility here. First factor, same, nature of solute and solvent, right? Nature of solute and solvent. Here our solute is gaseous in state. So you can say that the gases like hydrogen, oxygen, nitrogen, etc. dissolve in water only to a small extent. Then if you are taking the gas like HCl, NH3, etc., they are highly soluble. Similarly, here also we can say that polar solute are dissolved in polar solvent, non-polar solute are dissolved in non-polar solvent. Clear? Another example is also given here. Oxygen, nitrogen and carbon dioxide are much more soluble in ethyl alcohol as compared to water, right? Here also we need to focus on like dissolves like. Clear? Then what about the next parameter, temperature? How we can predict the temperature effect here? In earlier case, we have seen that in the case of dissolution process, whether it is endothermic or exothermic, we can predict the temperature change, right? But here in the case of solubility of gas in liquid, this process is always exothermic. So you need to keep in mind that this process is always exothermic, which means that if you are preparing the solution by adding gas solute in solvent, right? Gas solute in liquid solvent, you will get the solution by releasing heat. By releasing heat, which means exothermic process. So now we can predict how the temperature is changing here. What will be the temperature change here? If I am increasing the temperature, what will happen to the solubility of gas in liquid? I have already mentioned that this process is exothermic. Exothermic. According to Le-Chatelier's principle. According to Le-Chatelier's principle, what will happen? Already temperature is, heat is releasing, right? So in order to overcome this condition, what will happen? As the temperature increases, solubility decreases. Clear? Dhananjit, is that clear now? Because reason? Dhananjit, is that clear? Because it is an exothermic process, right? Exothermic process. If you have idea about the Le-Chatelier's principle, exothermic process means heat is releasing, right? Heat is releasing. So what will happen to the reaction? In order to overcome this condition, the reaction will move in the backward direction, right? Backward direction, which means solution is completely changes to solvent and gas, which means solubility decreases. Clear? Now let us talk about the effect of pressure here. There is a huge effect of pressure in the case of solubility of gas in liquid. So that we are introducing the new law known as Henry's law. Ready? Okay. What is the effect of pressure here? If I am taking gas in liquid, right? Gas in liquid. This solubility of gas in liquid is first introduced by a scientist known as Henry. So this particular law is known as Henry's law. And Henry's law can be defined as the mass of gas, right? Mass of gas. For example, if I am taking any of the gas solute here, this will be our mass, right? Mass of gas at a given volume of the liquid at a constant temperature, at a specified temperature. What will happen? It is directly proportional to the pressure, right? As the mass increases. If mass is directly proportional to the pressure, I can given it as m is equal to a constant K into P, right? Is that clear? This is the general definition for the Henry's law. The mass of a gas dissolved in a given volume of the liquid at constant temperature is directly proportional to the pressure of the gas. Directly proportional to the pressure of the gas present in equilibrium with the liquid. Clear? So M is proportional to the pressure. M is equal to a constant K into P. This is the general expression for the Henry's law. Is that clear? As already mentioned, M is the mass of the gas dissolved in a unit volume of the solvent and P is the pressure, K is the constant of proportionality. Now we are focusing on the main definition, how we are expressing the Henry's law, right? Okay, if anyone asking about the Henry's law, the main definition you have to given that the Henry's law can be stated as solubility of a gas in a liquid is directly proportional to the partial pressure of the gas in equilibrium with the liquid at a temperature. Clear? So solubility here we are focusing about the terms of mole fraction chi A. If I am taking the component A, the mole fraction solubility can be expressed in terms of mole fraction. This chi A is proportional to the partial pressure. This is the partial pressure of the particular component A. Then chi A is equal to, or we can write it as chi A is equal to a constant into PA. This constant is known as Henry's constant. Otherwise, we can also written the same Henry's law as PA is equal to KH into chi A. Clear? This is the mathematical expression for the Henry's law. Based on these equations, you may get more numerical problems in the JEE Main examinations. Clear? Okay. This is our Henry's law, right? P is equal to KH, Henry's constant into chi. If you are drawing a graph along with partial pressure along the y-axis and mole fraction along the x-axis, what you will be observing? There will be a straight line graph, right? There will be a straight line graph of slope is equal to KH. What is the KH is a Henry's constant here, right? So you can draw a graph like this in which, by use of Henry's law, in which y-axis contains the partial pressure of the particular solute and x-axis contains the mole fraction, right? So you will get a straight line graph here. Clear? As you can see over here, as the mole fraction increases, as the solubility increases, pressure also increases, right? That is our explanation for the Henry's law. Is that clear? So, how the value of KH is depends on the different gases. So, if you are talking about the nitrogen, oxygen or any other gases, this KH value has different values for different gases, right? That is given here. Different gases have the different values of KH at a particular temperature and pressure, particular temperature and particular solvent, right? So, let us see the values here. Yes. This is the particular value of KH for different gases at different temperature. Just go through the table and just give me the observation what you are giving here for this particular table based on the temperature idea. Right? What are you observing here? Same nitrogen gas is, right? Same nitrogen gas. One is at 293 Kelvin and other is at 303 Kelvin, right? 303 Kelvin. What you are observing the value of KH here? What is happening there? Whether the KH value is increasing or decreasing? That is the question. Is my question is clear? If you are talking about the Henry's constant for different gases, if you are changing about the temperature here, right? Kiran Reddy, what is the answer? Just focus on the nitrogen gas only. One is at 293 Kelvin. KH value is 76.48, right? 76.48. Then what about nitrogen? The same. Nitrogen at the 303 Kelvin, 88.84. What will happen to the KH value? Whether it is increasing or decreasing? From here to here it is increases, right? So as the temperature increases, what will happen to the KH value? KH value also increases. Then according to Henry's law, what will happen to the solubility? What will happen to the solubility? Clear? Yes, KH value also increases here, right? KH value increases. As the KH value increases, according to Henry's law, solubility also increases. Clear? That's why we are saying that aquatic species are generally comfortable in the cold water than the warm water. Clear? Clear? And let us talk about how the KH values depends on the different parameters. Right? So, Henry's constant is always a constant or the function of the nature of the gas, right? It is a function of nature of the gas here. So, greater the value of KH, what will happen to the solubility? This is our Henry's law, right? P is equal to KH into chi. Then if you are talking about the KH here, KH is equal to P by chi, right? P by chi. If you are talking about this constant pressure,
That's last. Pen options. Continue.
okay, this is our Henry's law, right? P is equal to KH into chi. If you are talking about the KH here, if I am taking the pressure as a constant here, what will happen to the solubility here? How Henry's constant and solubility are depends. This is constant, right? At the same pressure it is constant. So it is inversely proportional, which means that greater the value of KH, lower is the solubility of the gas at the same partial pressure. Clear? Yes, P is equal to KH into chi, right? Then KH can be defined as P by chi. So if you are taking the pressure as constant here, what will happen to the relation here. As the KH value increases, solubility decreases. Clear? Mudra, I didn't get your question. What is your question? So the last parameter which is depends on the value of KH is, it is increased with increase in temperature, right? KH is increased with increase in temperature, implying that solubility decreases with increase in temperature at the same pressure. This already we have seen in the table, right? If you are focusing about the nitrogen gas at different temperature of 293 and 303 Kelvin, what will happen to the KH value? KH value increases, which means solubility also increases, right? Okay, is that clear? Now let us talk about the applications of Henry's law. As you already seen about the soft drinks, right? Cola, soda water and everything. In order to increase the, right here, this is our soda water, right? So in order to increase the solubility of carbon dioxide in soft drinks and soda water, what is doing here? The bottle is sealed under high pressure, right? How we can apply our Henry's law here? How we can apply our Henry's law here? Based on the pressure. Are you getting my point? Partial pressure is equal to Henry's constant into solubility in mole fraction, right? Partial pressure is directly proportional to the solubility here. If the soda water is containing carbon dioxide, right? Carbon dioxide as the solute as the gas here. So if it is sealed under high pressure, as the pressure increases, what will happen to the solubility according to Henry's law? Increases, right? So in order to increase the solubility of carbon dioxide in the soft drinks, this bottle is sealed under high pressure. Clear? Okay, what about the second application here? What are you observing in this image? A climber, right? So here, how we can apply our Henry's law? This is a mountain climber. So here there is a condition happening. Low blood oxygen level causes anoxia. There is a health condition known as anoxia. So how we can apply the Henry's law here? This climber is going to the high altitudes, right? High altitudes. What will happen to the pressure there? Whether it is high or low as compared to the ground level. Yes. Climbing mountain without oxygen cylinder, right? Correct. So what will happen to the pressure there in the case of mountains? High pressure, right? As compared to the ground level, there will be high pressure there. So at the high altitudes, the partial pressure of oxygen is as compared to the ground level, pressure is very low, right? Yes. Okay. Here in the case of high altitudes, if he is moving to the high mountain area, what will happen to the pressure? Partial pressure is decreases. As according to our Henry's law, what will happen to the solubility? In the case of dissolved oxygen, what will happen there? Low concentration of oxygen, right? Low concentration of oxygen, which leads to a condition known as anoxia, right? Anoxia, difficulty in breathing. That is a condition known as anoxia. That is why these mountain climbers are always using the oxygen cylinders. Clear? Is that clear? Just let me know in the comments. Okay. Is there any other applications in the real life example about the application of Henry's law? Anyone? Is there any other applications? No? Have you heard about the scuba divers or sea divers? So in the case of sea divers or yes, swimmers or scuba divers, sea divers or scuba divers, right? So in the case of that, what will happen to the pressure in the underwater? From underwater to surface, if they are moving, what will happen to the pressure? High or low? Yes, at depths it will be high, right? At the depths it will be high if they are moving towards the surface. Outside the water, what will happen to the pressure? It will become low, right? Low pressure is there. So according to our Henry's law, what will happen to the solubility again? Solubility also decreases, right, according to the Henry's law. So when they are moving from the underwater level to the surface level, pressure decreases as according to the Henry's law, solubility also decreases. So what will happen? Similarly, there is another health condition is known as unable to breathe condition, that is known as bends. So in order to avoid these particular conditions, they are using a cylinder in which, yes, cylinder or tanks in which helium is involving, right? Helium is involving, high pressure helium is involving. Clear? Just go through the NCERT textbook, it will be detailedly given in your NCERT textbook as the application of Henry's law there. Clear? Okay, Mudra, what will be the answer for that question? Instead of nitrogen or oxygen, why we are using helium? Okay, this is the answer for that question. Clear? If you are talking about the helium, right? What is the KH value there? KH value. Maximum as compared to nitrogen and oxygen, right? Are you getting my point? So in the case of helium, the KH value is maximum as compared to nitrogen and oxygen. That is why the scuba divers or sea divers are using helium instead of nitrogen and oxygen in the case of tanks, right? In order to avoid the condition of bends. I hope it is clear. Okay. Now let us talk about the limitations of Henry's law. As we already seen about the applications of Henry's law, right? We have seen many real life examples to explain the Henry's law. Then also they have some limitations. What are they? The main condition is that the pressure should be low and the temperature should be high. Then only it works under the consideration of Henry's law, right? Which means the gas should behave as an ideal gas here at a low pressure and high temperature. Clear? Then the second condition is that gas should not undergo any dissolution, any dissociation, right? Then only our Henry's law works here. Clear? Okay, that's all about the Henry's law here. So far what we have discussed in the today's class, you can just recall the topic that we have covered. And again one more question is here. It is based on the applications of Henry's law. What will be the answer for this question? The low concentration of oxygen in the blood and tissues of people living at high altitude is due to. We have already seen, right? In the case of anoxia condition, what will happen to the pressure there, atmospheric pressure, in the case of high altitudes? Okay, what is the answer for this question? Option 2, right? Low atmospheric pressure. At the case of high altitudes in the mountain cases, what will happen to the atmospheric pressure? Atmospheric pressure decreases, so that solubility also decreases according to Henry's law, right? So option 2 will be the correct answer. Clear? So just go through the previous questions which is based on the Henry's law. You may get more numerical problems in the case of application of Henry's law here. After completing the session, completing the whole chapter, I will be coming back with the PYQs of the solution chapter. Then we will discuss detailedly. So in this class, we have discussed about the solubility term, right? What do you mean by solubility? How solubility is affected by the temperature, pressure, and nature of solute and solvent. Then solubility of gas in a liquid. Then we introduced the Henry's law. We have seen about the applications of Henry's law, limitations of Henry's law. I hope it was clear for everyone. Do you have any doubt? You can ask. Otherwise, we can wind up the session for today. Okay, again a gentle reminder about the AATS for the JEE Advanced 2025. Finally, JEE Main exams are over. The next phase is JEE Advanced. So Infinity Learn is providing you an all India test series by including some mock test here. So you can enroll the fast. Then again there is another opportunity like college predictor. You might have your scores in your hands, right? JEE Main exam scores. The link will be provided in the description. You can just put your JEE Main scores here. Then you will get a list of colleges like IITs, NITs and private colleges according to your score. So this is a big opportunity for you to identify which college you will get according to your score. Then, if you are not getting any good ranks in the JEE Main exam, no need to worry. There is another private exams are available there. Again, Infinity Learn is providing test series for these particular private engineering exams. You will get 70% off by using best 70 off code here. So don't miss the opportunity here. Enroll fast. Okay, Mutta, this is the right time to crack for JEE Main exam. If you are studying in the 9th standard, you have more time to crack the exam. So study hard, do the smart work here, then you will crack the JEE Main exams in the first attempt. Okay, that's all about from my side for today. I hope you guys have enjoyed the session. If you really like the session, hit the like button, subscribe our channel, share this particular session to your friends and family also. Then if you want to get the notes here, you can join our Infinity Learn Telegram channel. You will get the session PDF after every session here. So make sure that you will be attending every class with me in the next session also by 5 to 6 here. Till then, bye bye all of you. Take care.